Okay, so here's a question from section 2.8, a particularly difficult one, I think, a little more computationally intensive, but it'll be a good test for us to see how careful we can be. So, we're given this function g of t. Our goal is to find the derivative and state the domain of the function and its derivative. So, basically combining a bunch of stuff we've already seen, right? Taking derivatives using the limit law, or limit definition, and finding domains. So, the derivative of g, so g prime of t, is given by the limit as h approaches 0 of g of t plus h minus g of t all over h. And so plugging stuff in, this is 1 over square root of t plus h minus 1 over square root of t all over h. Oh, I dropped my limit sign. Limit as h goes to 0. Okay, good, minus a point. So, let's see. I think I want to get common denominators here first. So let me go ahead and simplify this by getting common denominators. So this is the limit as h approaches 0 of, so the first term I need a square root of t over square root of t to make up. So root t over root t times root t plus h. Okay. Minus, and the second term I need root t plus h over root t times root t plus h. Okay, and all of this is over in h, of course. And so I get the limit as h goes to 0 of root t minus root t plus h over root t times root t plus h. And then all of this is over h, so I can rewrite that by just multiplying by the reciprocal, right? 1 over h, or just putting the h in the denominator here. Okay, so I've done sort of two steps in once here. I've combined this numerator into one fraction, and then instead of dividing it by h, I have multiplied by the reciprocal 1 over h. Just a little easier to look at. So now, let me just rewrite it one more time. So now we're kind of in the thick of it, right? So I got root t minus root t plus h over h times root t plus h. And now we might be tempted to try to plug in h equals 0, but if you do, you still get a 0 over 0 here. So we still have to do more work. Now I look at this, I see some square roots, so probably I'm going to conjugate. Let's go ahead and conjugate that numerator. So I'm going to multiply by root t plus h over root t plus h equals, limit as h goes to 0. So when I FOIL out the numerator, right, I am going to get t, middle outer terms cancel, minus the quantity t plus h, right? When I square the square roots, they go away, over, you know what, I'm going to leave the numerator not FOILed, so I'm going to leave it h times root t plus h times root t plus h. Okay, I'm just being really careful about my arithmetic. My numerator is nice. I noticed t minus t, so I'm going to do some cancellation upstairs. So I get the limit as h goes to 0 of minus h, right? Careful of that minus sign, over h times root t plus h times root t plus h in parentheses. Okay. H's cancel. I'm happy, right? Because now I'm going to have something I think I can plug h equals 0 into without consequence. So just rewriting it, root t plus h times the quantity root t plus h equals. So if I plug in h equals 0, what am I getting? Negative 1 over, so root t, right? So that's actually a t overall, right? These first two things become a t overall, times root t plus root t. Interesting. So I get minus 1 over, this is 2 root t, so 2 root t times t. Alrighty. So what do we learn after all this? I'm going to write g prime underneath it. G of t is 1 over root t. G prime of t then must be minus 1 over 2 root t times another t. Alright, so let's talk about domain. So the domain isn't so bad here. G, I know for square root I can't plug in something less than 0. But in this case I also can't plug in 0 because I'll divide by 0. So together I know the domain of G must be 0 to infinity, not including 0. Right? Not including 0 because I'd be dividing by 0. And for G prime, actually it's the same exact problem, isn't it? Right? In this case, the domain of G prime is exactly the same as G. Okay, because I have the same square root issue. And I have an extra t now, but okay, still it's just division by 0, so I don't have to worry about that. Okay, so in this case, the domains are equal. Whew, bit of a workhorse problem. It's not so bad if you think about it very methodically, right? So I think a good lesson to take away from this is, yes, sometimes we are faced with a lot of algebra, but as long as we're being careful and neat with our work and following things methodically, right, getting common denominators, then conjugating, just being able to, make sure to distribute and all that jazz, these problems will work themselves out. We have to be patient. We have to be very careful, right? Something I think is kind of interesting, after doing this exercise, we can use the power rule to check if our answer was correct. So G of t originally was 1 over root t, which I can think of as t to the minus 1/2. And so G prime of t using power rule would be minus 1/2 t to the minus 3/2, which I can write as minus 1 over 2 t to the 3/2. Well, is this the same as this? Well, it is. If I were to combine the root t with the t, that'd be a total of t to the 1/2 times t to the 1, which is t to the 3/2 overall. So these are the same answer. Of course, power rule is a lot nicer, right? But it is good for us to remember where that all comes from, right? That we know all these little tricks from section 2.3. So if push came to shove, we could use the limit definition to confirm our answers. Okay, tricky problem. Hope you learned something. If you have any questions, let me know.